This problem is requires the understanding of the elastic potential energy in a spring. If you remember, the elastic potential energy stored in a spring is equal to half kx squared. The potential energy, I'll just call it elastic potential energy. This is equal to half k x squared. K is the spring constant and x is the displacement. This is elastic potential energy. Elastic potential energy. Okay. K is a spring constant. Spring constant. Okay. Now, what is asking here? Let me explain this problem first. So you have a spring, and this initially this spring is neither compressed nor stretched, and that we call this we call equilibrium position. That means it is neither stretched nor compressed. And then you apply the force and you stretch it. And let's say you stretch it here. And then you again further stretch it. Again you stretch this one. So it says, so this stretching, we call this as an x1. x1 from this point to this point, which is 1.4 meter. 1.4 meter. And from this point to this point, it is 2.9 meter. So first you stretched it to 1.4 meter and then you stretch it to 2.9 meter. And it says if you, the total amount of work done from this point, from point A to point B, the total amount of work done in stretching the spring from point A to point B is 49 joule. What is this? And it is asking you to calculate the spring constant, which is K. How do we solve this problem? So if you stretch this spring, the work done you did in stretching the spring is stored in the form of elastic potential energy. So the energy is neither it cannot be destroyed. It is always stored in the some form of energy. In this case, all the work done is stored in the form of elastic potential energy. So if I move from this point A to the point B, the total amount of work done in going from point A to point B is stored in the form of potential energy. So what I can write down here, work done, this work done is equal to the change in the elastic potential energy. Change in the elastic potential energy. What does that mean? What is the potential energy at this point and what is the potential energy at this point? The difference of this potential energy has to be equal to the amount of work done. Okay, so now let's calculate this one then. So this work done, let's say this is work done is W. At this point, what is the potential energy? Half this is equal to negative, because the difference in the potential energy, we have to get it, is equal to half k x1 squared. And this change in the potential energy is equal to the work done. Okay, let's solve this one. Half k x2 squared minus x1 squared. We need to find out k, that this is 2 times w over x2 squared minus x1 squared. 2. What is the amount of work done? Which is 49 joule. 49. X2 is 2.9. 2.9 squared minus 1.4 squared. And if I just plug in all the value, then the answer you will get is 15.19. And the unit for this one is Newton per meter. This is not a kinetic energy, this is just the spring constant. Okay.